Hello everyone, welcome to my channel. Today we'll learn how a bottle jack works. So, if you've ever been curious about this handy tool, then you come to the right place. Let's get started. Before we jump into the inner workings of a bottle jack, let's first look at the key components involved. A bottle jack is a hydraulic lifting device designed to raise heavy loads. It consists of a cylinder-shaped body, hence the name, bottle jack, which houses the hydraulic system. The bottle jack has a large base, providing stability when in use. This is the saddle. It's mounted on top of the main piston and directly contacts the load being lifted. The saddle may have textured or grooved surfaces to improve grip and stability. It provides a secure point of contact between the jack and the load. On certain models of bottle jacks, the saddle may be threaded. By rotating the saddle manually, it can be adjusted vertically, allowing for fine-tuning of the height when necessary. This is the handle. By pumping the handle up and down, you apply pressure to the hydraulic system, causing the main piston to rise, gradually lifting the load. This is the release valve. To safely lower the load, a bottle jack is equipped with a release valve. By turning the valve, you can gradually release the pressure in the hydraulic system, allowing the load to descend in a controlled manner. We'll take a look at the release valve in more detail later in this video. Now let's take a closer look inside the bottle jack. This is the oil reservoir, filled with hydraulic oil, which act as a working fluid for the system. It's important to ensure the reservoir is adequately filled for proper operation. The hydraulic oil within the reservoir is not pressurized. This is the oil plug. The oil reservoir is typically filled to the lower rim of the oil plug hole. This is the pump cylinder and piston. This is where the hydraulic fluid gets pressurized. The handle is inserted into the handle bracket, which is directly connected to the pump piston. When you pump the handle, you basically operate the pump piston. Next, we have the main cylinder and piston. The hydraulic oil coming into the main cylinder is pressurized, pushing the main piston up and lifting the load. Both pistons have a seal around them, ensuring a tight fit within the cylinders. The seals prevent any fluids from leaking out, maintaining the pressure necessary for lifting heavy objects. Finally, we have the ball check valves. They allow the hydraulic fluid to flow in one direction and prevent it from reversing flow in the opposite direction, ensuring that the load remains lifted, even when the pumping action stops. The valve operates based on the pressure differential between the input and output sides. We have a two-ball check valve in the bottle jack, one for the pump cylinder and one for the main cylinder. A ball check valve typically uses a spring-loaded or free-floating ball that rests on the sealing seat to close the valve orifice. The check valve in today's example is using a spring-loaded ball. The valve seat is conically tapers to properly guide the ball, providing a positive seal and preventing backflow. When the oil pressure from the inlet sides exceeds the pressure from the outlet side, the ball is dislodged from its seat, allowing fluid to flow through. When the outlet pressure exceeds the inlet pressure, the ball closes with the back pressure or with the spring, effectively closing the orifice. Let's now understand the bottle jack working principles. A bottle jack operates in two principles. The first principle is the law of the lever. A lever amplifies an input force to provide a greater output force, equaling the ratio of the output force to the input force. There are three classes of lever depending on the location of the load and effort with respect to the fulcrum, also called the pivot point. The first class lever, the fulcrum, is in the middle and the force is on one side and the load is on the opposite end. Much like this seesaw. Other examples include scissors and pliers. Here's the force, the fulcrum, and the load. Second-class levers have a load between the force and the fulcrum. For example, with this wheelbarrow, here's the force, the fulcrum, and the load. A nutcracker is an example and a stapler. A third-class lever has the fulcrum on one end, the force in the middle, and the load on the other end. For example, with this hockey stick, this rake is a third-class lever and a hammer. A bottle jack uses a Class II lever, where the load is located between the effort and the fulcrum. The movement of the load is in the same direction as that of the effort. If, for example, The lever arm from the fulcrum to the input force is 10 times larger than the lever arm from the fulcrum to the pump piston, then the input force will be increased by a factor of 10. The second principle is Pascal's law. The hydraulic technology, based on the famous theory, coined by well-known physicist, Blaise Pascal. Mathematician, Blaise Pascal, was born on June 19, 1623, in Clermont-Ferrand, France. Pascal's law states that, when pressure exerted anywhere, upon an enclosed liquid, is transmitted undiminished, in all directions, to the interior of the container. As per his principle, allows large forces to be generated with relatively little effort. As illustrated, a 5-pound force exerted against a 1-inch square area creates an internal pressure of 5 pounds per square inch. This pressure, acting against the 10 square inch area, develops 50 pounds of force. Exerting a small force on the pump piston, which have a small cross-section area, will generate a pressure in the fluid. Now, let's see how the bottle jack works. In its initial position, the main piston is fully retracted into the cylinder and the release valve is closed. As you pump the handle, when the pump piston moves up, the hydraulic oil is sucked from the oil reservoir to the pump cylinder through an inlet passage. Just before entering the pump cylinder, the fluid lifts the steel ball, allowing the fluid to pass through it freely. As the pump piston subsequently moves down, it pressurizes the hydraulic oil, pushing the steel ball down against its seat, closing off the pathway back to the oil reservoir and forcing the hydraulic oil through the second passage towards the main cylinder. Simultaneously, the steel ball in the main cylinder is lifted by the incoming pressurized oil, allowing the fluid to flow in. As the hydraulic fluid enters the main cylinder, it pushes against the piston, causing it to rise. The piston's upward movement transfers the force to the object being lifted, allowing you to raise heavy loads with relative ease. When the piston moving downward reaches the end of its stroke, gravity causes the ball in the main cylinder to close, and the pressurized oil keeps it shut, preventing hydraulic oil from flowing back into the pump cylinder. The pumping process can now be repeated until you reach the desired height. The more you pump the handle, the longer the piston extends, allowing greater lifting height. Finally, when you're done lifting and you want to lower the load, you can slowly turn the release valve stem counterclockwise, typically using the handle as a tool. This action opens the valve, allowing the pressurized hydraulic fluid to flow from the main cylinder back into the oil reservoir, gradually releasing the pressure in the system. As a result, the piston descends and the object is safely lowered. I hope you found this video informative and interesting. If you did, don't forget to give it a thumbs up and subscribe.